Hello everyone and welcome to this session on advanced data processing integrity Kafka and Spark for the real-time prediction. In this video, we will be exploring the end-to-end process of setting up Kafka producer to stream real-time data, configuring a Spark streaming job to consume this data, and ultimately using a pre-trained machine learning model to make prediction on the live stream. I will guide you through each part of the code as we build it step by step. Now let's move to the first part of our project. Here we will generate some synthetic data to simulate real-time user activities and build a machine learning model that will predict user behaviors. First, we import pandas and random to help us create and structure our synthetic data. Now let's define our data generation parameters. We start by creating user IDs, a list of 100 unique users IDs using the list convention. Next, we define possible activities user might perform: click, view, purchase, and add to cart. We also add a labels list which will represent our binary labels 0 or 1, indicating two categories like non-conversion or conversion. Now we will generate our synthetic data. We will initialize an empty list called data to store each record as a dictionary. For each entry, we randomly assign a user ID, an activity, and a timestamp using a specific range. Finally, we will assign a label by randomly choosing between 0 and 1. We repeat this 100 times, simulating 1000 user interactions. Once all data is generated, we convert our list of dictionaries to a pandas data frame, making it easy to save as a CSV file. We save this as a data.csv. Then print a confirmation message that the synthetic data has been saved. This data will serve as our input data for modeling and streaming. Now let's work on building a machine learning model using PySpark. We will start by importing the string indexer and vector similar from PySpark ML library to help us prepare our data. We also input logistic regression to build our model and Spark session to create a Spark session. We begin by setting up a Spark session using Spark session.builder, giving our app the name Kafka read write, and specifying the Spark SQL Kafka package to integrate with Kafka later. And we set master to local with for course local. Next, we load our synthetic data from data.csv into a Spark data frame called historical data by setting header equals to true and info schema equals to true. Spark automatically recognizes the column names and infers data types. To prepare the data, we first use string indexer to convert the categorical activity column into a numerical activity index. This is important because machine learning models work with numerical data. We then transform historical data in the indexer to get a new data frame. Now we use vector similar to combine activity index into a single features column. Creating a feature vector Spark leads to model training. This assembled data is stored in our training data. For the model itself, we initialize the logistic regression specifying features as our input and label as our target column. We feed the model on training data, turning it on our labeled example. And finally, we save the trained model with model.save to specified path. This saved model will later be used for making prediction on streaming data. Once saved, we train a confirmation message indicating that the model has been saved, trained, and saved. We loaded the synthetic data, index the activity column, and assembled it into a features vector. Then we trained a logistic regression model to predict user behavior based on the activity types, and the model is built for future use. Now let's move to real-time data generation. We will create a Kafka producer that sends live user activity data to a Kafka topic. Before we go ahead, let's set up Zookeeper and the Kafka server. In order to manage and coordinate Kafka brokers, we will first start the Zookeeper service. Once Zookeeper is running, we can then start our Kafka server. This setup will allow us to use Kafka to handle real-time data streaming. Now let's check list of Kafka topics. You can see there is no Kafka topics because we haven't created any Kafka topic. When we will execute the Kafka producer code, Kafka topic will create. Now let's move to Kafka producer code for real-time data generation. Next, let's set up Kafka producer to simulate real-time data streaming. We start by importing the Kafka producer class from the Kafka library, along with the JSON type and the random library, which we will use the data formatting, timing, and random data generation. We configure the Kafka producer with the strap underscore servers equals to localhost colon 9092, which connects to our Kafka broker, and the value serializer option serializes each data message to JSON format, encoding it to a UTF-8 so it's ready for transmission. And then we define our data sources, user IDs, and activities. Here, user IDs is a list of unique users, and activities includes for websites. They might perform click, view, purchase, and add to cart. In the loop, we continuously generate a random event every half second. For each event, we randomly select the user ID and activity. We capture the current timestamp in milliseconds using time function. This structured data would usually represent user's activity. Using a producer.send, we send each data event to the user activity Kafka topic. To monitor the flow, we print the message to the console and then pause for half a second, which type.sleep function 0.5. This loop creates a steady of stream on the activity data, mimicking real-time interaction on our Kafka topic. Now let's run it, and here you can see the output. Now we are ready to read data from Kafka in real time using Spark streaming. Here we can set up our Spark session to connect to the Kafka topic and parse the streaming data. Now let's set up our Spark streaming job to consume real-time data from Kafka. We start by importing necessary Spark libraries, including Spark session, function for parsing JSON, and data types for defining our schema. First, we create a Spark session, setting the app name to Kafka read write and adding the Kafka SQL package, which enable us to read directly from Kafka topic. We also configure Spark to use for our local calls with master. Next, we define the schema for the data we expect from Kafka using stub type. This schema envelopes three fields: user ID and activities, and both string and timestamp, which is a longer integer present time in millisecond. To consume data from Kafka, we use spark.readStream to read from the user activity topic. We specify the topic broker address with kafka.bootstrap.servers. In the next step, we parse the Kafka message by selecting and casting the value field as a string. Then we apply the JSON schema to this value with from JSON, mapping each field in the JSON message to a column in a data frame. Finally, we set up our output. We use write string with output mode open to continuously display new rows in the console. By calling await termination function, we keep the stream active and allowing Spark to process data as it arrives in real time. Here, let's run this. Here you can see the streaming data. Finally, let's load our retrained model and make prediction on the streaming data. In this part, we are using pre-trained model to make prediction on streaming data. Easy to understand, I will write code again here. We begin by loading two pre-trained models, logistic regression model for prediction and stream induction model to convert activity labels into a numerical form. We specify their paths with load, enable us to reuse these models without retraining. Okay, I forget to save string indexer model. Now let's save it. Next, we apply the string indexer model to transform the activity labels in numerical data, creating a new column activity index with numerical labels. This index data is then passed to a vector assembler which combine the activity index column into a single features vector needed for model prediction. With modern.transform, we make prediction on the streaming data which output the prediction data frame. This data frame includes key columns like user ID, activity, the probability of each class, and the final prediction label. Finally, we set up streaming query to display the prediction in real time. We select relevant columns and use write stream to output each batch in the console. Calling await termination function keeps the stream active and allowing us to see prediction as a new data flows in. Let's execute code now. Now that our code is running successfully, let's take a look at the first thing. We will see the stream of data coming from Kafka, and the professor sends data with user ID, activities, and the timestamp. These messages are processed in real time, and as they are read by Spark, they are passed and indexed using the string indexing model. This means that each activity like a click or view is converted into a numerical index, which is then used as a features for our prediction model. As the stream continues, the logistic regression model will make prediction on each incoming record. As the output will display the user ID, activities, and the probability for each class and the final prediction. Here, probability represents like a likelihood of each class 0 or 1. Prediction columns shows the model predicted class based on the probability. This string will continuously shows prediction as the new data flows in, allowing us to see the model performance in real time. Thanks for watching. See you in the next video with next topic.